All right, good afternoon, good morning. We are going to be starting lesson 3 from chapter 1. So we do 2 new terms, we have 2 formulas, and then some practice problems to go through. Okay, so today we're going to talk about the midpoint formula. We're going to talk about segment bisector and the distance formula. Okay, so to get started, midpoint. The point that divides a segment into 2 congruent segments. So if you look at this diagram, we have segment AB, and M is right in the middle, and I know it's right in the middle because these 2 tick marks tell me that this segment AM is the same length, is congruent to this segment MB. Okay, so that means that M is the midpoint, it's in the middle, and as I already said, segment AM is congruent to segment MB. Or remember, notation super important. You could say the length, the distance from A to M is equal to the distance from M to B. A segment bisector. Okay, a segment bisector is a point, a ray, a line, a segment, or a plane that intersects the segment at its midpoint. So we start actually with the same diagram as above. We have segment AB. Okay, M is in the middle. It's the midpoint because of the tick marks. I know that M is in the middle. And then we have this line that goes through the midpoint. So that line is what we refer to as the segment bisector. Bisector, when you hear the word bisect, I want you to think of cut in half, cuts into 2. All right, bi meaning 2. So we're cutting this segment into 2 equal pieces. All right, so CD, line CD, is the segment bisector of line AB, is what it says over here. Okay, so bisect, then cut in half, cut into 2 equal parts. All right, let me erase the board and get up the formulas that I want to go over with you guys. Okay, so we first have the midpoint formula. All right, this midpoint formula can be used to find an end point of a segment or to find the midpoint of a segment, depending on what information is given, and I'll go through examples of both. But all you need to do is you have to find the average of the x coordinates and the average of the y coordinates of its endpoints. So the formula is that the midpoint is equal to the average of the x's. So you take x sub 1, x sub 2, and divide by 2. And then the average of the y's. Y sub 1 plus y sub 2 divided by 2. Okay, so actually before I move on to the distance formula, let me do an example using the midpoint formula. All right, so is this a dry? Yes, it is dry erase. Okay. Example. I'm going to say, given end points P and Q, find the midpoint of segment PQ. Okay, so again, if you're given that P is -4, 3, and Q is located at 0, 5, we want to find the midpoint. So let me quickly sketch a visual for you guys so you kind of understand what we're doing. So P is at -4, 3. If you have graph paper, it's always helpful to have actual graph paper to make this real accurate. So this is P, -4, 3. And then Q is at 0, 5. This is Q, 0, 5. That's your segment. And I want to find the midpoint. Okay, now I know, like, visually, just kind of looking at the diagram, I know the midpoint is going to be somewhere like right around here, but I want to know the exact coordinate. So I'm going to use the midpoint formula, but then I'm actually going to also visually show you, kind of using slope and rise and run, how to also figure it out from the graph paper. All right, so the formula says you're going to take the x's and average them, add, divide by 2, and the y's and average them. And you can always label, this is x1, y1, this is x2, y2, and then plug into the formula. So x1 and y1, or excuse me, x1 and x2, you're going to add them together, -4 plus 0, and divide by 2. And then you're going to take your y's, that's what it says, take the y's, 3 and 5, add them together, and divide by 2. So -4 plus 0 is -4. -4 divided by 2 is -2. 3 plus 5 is 8. 8 divided by 2 is 4. So the midpoint should be located at -2, 4, which if we kind of approximate where that should be, -2, 4, right there, which it looks like it is, okay? Now I said I was also going to kind of show you using the graph and using rise and run. So from this point to that point, if I was to talk about rising and running, I'd have to rise 1 unit and run, where am I, -4 to 0, I'd have to run 4 units. So if I'm trying to find the midpoint, that means I only want to go up half as many units and over half as many. So instead of going up 1 whole unit and over 4 units, I could just go up, I'm sorry, I just want to make sure I am correct. It's not up 1. That's wrong. This is 4, 3, and this is 5, so that's up 2. Sorry, guys. Counted wrong. Again, using actual graph paper, you probably won't make that mistake. But from that point to this point, you have to go up 2 and then over 4. Let's try this again. So I only want to go up half as many and over half as many. So instead of going up 2, I'm going to go up 1 and then over 2. All right, so up 1 unit and then over 1, 2 units puts me there. And then I can go to the origin and figure out the location, and I can see it's over 2 and up 4. Okay, so those of you that are more algebraic in your thinking, you probably are like, it's faster just to use the formula. If you're more visual in your thinking, maybe you do this on graph paper, maybe you do it in your head, you can just visually see it. Okay, but I wanted to show you both. All right, now another situation would be if I gave you one endpoint and the midpoint and asked you to find the other endpoint. Okay, so let me set that up for you guys. All right, so given endpoint P, I kind of have to erase this. Let's see. So given endpoint P and midpoint M, find the other endpoint Q. Okay, so let me figure out which coordinates I want to give you guys for this one. Let's see, we'll do this one here. So we'll say that P is located at 7, 2. M is located, the midpoint is located at 1, -2. We're trying to find Q, the other endpoint. All right, and just like the last example, I'll show you both algebraically how to do it and also using the graph how to do it, okay? So let me come over here. Let's plot what we have and look at it visually first. So 7, 2. That's P. And then 1, -2. That's M. That's the midpoint. Okay. And we don't know where Q is, the other endpoint. All right. So just kind of visually looking at this, if this is the midpoint and that's the endpoint, I know my other endpoint is probably going to be like over here somewhere, right? If this is the middle, that's the midpoint. That's one endpoint. The other endpoint has to be this direction in order for M to be in the middle. All right, so I have a general idea. It needs to be in this quadrant, somewhere down here. Now, again, you can use slope to help you figure this out. You can figure out how many units you went up and over, and then do the opposite. Go down and over. So what I mean by that is to get from M to P, I have to go up 1, 2, 3, 4 units, right? I have to go up 4, and then I have to go over, I have to remember if that was all the way set, 6 units it would be. 1, 2, 3, 4, 5, 6. So it's up 4 over 6. So if you do the opposite, if you go down 4, this way 6, so 1, 2, 3, 4, go down 4, and then over 6 units. So 1, 2, 3, 4, 5, 6. Put it there, right? That should be Q. So now to figure out that coordinate, go to the origin. We went down and then over. So it's 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5. So it's down 6 to the left 5. And hopefully I counted. Oh, no. Did I count wrong? Oh, I'm making a mistake. We don't go down and then left when that's how we do slope, but not to find the location. Go over first, then down. My mistake. I'm sorry. So it's over 5, down. Let's count again. So it's over 1, 2, 3, 4, 5, and then down 1, 2, 3, 4, 5, 6. There we go. Again, having actual graph paper with the grid lines, you won't be making all these little mistakes I am because it's more accurate for you to visually see. Okay, now, so that's how you can do it from the graph paper, or if that's just the way your brain, you kind of visually look at it and can figure it out, great. Now, I am more algebraic in my thinking, so what I'd want to do is I'd want to think of P, this is my x1, y1. My Q, that's my x2, y2. And I'd want to set up the formula, okay? So I know that if I take my x's, this x and my unknown x, and I average those, they have to equal that point there, okay? So if I take my x1, which is 7, my x2, which I don't know, if I add and divide by 2, that's going to give me the x of the midpoint, which is 1. So that's one equation I'm going to have to solve for. Same thing for my y's. If I take my 2 y endpoints, right, these are the endpoints, this is the midpoint. So if I take my endpoint of 2, my unknown endpoint, if I average them, so add and divide by 2, that's going to equal the midpoint of -2. Okay. So then I'm going to multiply both sides by 2 to solve the equation. So I have 7 plus x2 equals 2. And then I'm going to subtract 7 from both sides. So I have x2, right? If you have 2 minus 7, that's going to give you a -5. Same kind of process over here. Start by multiplying both sides by 2 to clear out that fraction. So now I have 2 plus y sub 2 equals -4. Subtract 2 from both sides. And you have y sub 2 equals -6, which is what I found over here, -5, -6. Okay. All right, let's do something else. All right, let me break down the distance formula. So in a previous lesson, we found the distance between 2 points on a number line, right? And they were, you just had to jump units or take the absolute value of their coordinates and find the distance. However, we're not always going to just be on a number line. We could be in our coordinate plane, okay? So we have a distance formula that we use. Put the right piece of paper on that. Good. Okay, so distance formula. Okay, and to find the distance between 2 points, what you do is under a square root, you take the difference of the x's squared. So x2 minus x1 squared plus the difference of the y squared. y2 minus y1 squared. Okay. So for an example, find the example I wanted to. Here we go. If I say, find the distance between -3, 4 and 1, -4, okay? What you can do if you're going to use the formula is label one of the coordinates x1, y1, and the other coordinate x2, y2, all right? And then plug into the formula. So it's the absolute value, or not the absolute value, excuse me, the square root of the difference of the x's. So 1 minus -3 squared plus the difference of the y's. -4 minus 4 squared. All right, 1 minus -3, same change. So that's really 1 plus 3, so that's 4 squared. Same change, so it's really -4 plus -4, which is going to be -8 squared. All right, order of operation, I'm going to square first, and now I have 16 plus 64, all under the square root. So that's going to give me 16 plus 64 is 80, square root of 80. Now, if the directions say to round to the nearest tenth or hundredth, then you can plug that into your calculator and get a decimal approximation. But if it doesn't say to round, you should give your answer in simplified radical form. All right, so you have to think of two numbers that multiply to 80, and if you can think of a perfect square number, that's always best, okay? So you might need to go and do a factor tree, all right, if you're not sure what the factors of 80 are or what a perfect square factor of 80 might be. So maybe you just start with 2 and 40, okay, and then 40 breaks down to 2 and 20, and then 20 breaks down to 2 and 10, and then 10 breaks down to 2 and 5. So, let me swing this up here. Instead of the square root of 80, you can write it as 2 times 2 times 2 times 2 times 5. This is one way of breaking down square roots. So it's 2 times 2 times 2 times 2 times 5. You circle a pair of 2's, you circle another pair of 2's, so you take a 2 out for that group and a 2 out for that group, multiplying together to get a 4, and you have 4 root 5. Okay, just a quick review of simplifying radicals. All right, so that is how you use the distance formula. Now again, if you are more visual in your thinking, I'll just give you another idea, something else to think about for this problem. So let me erase the algebra. Now the distance formula is related to Pythagorean theorem, which you guys should know from Algebra 1. So let's take a look at how this is related to Pythagorean theorem, in case you want to think about it differently. All right, so if I plot the points, again, having actual graph paper would make this a little bit easier. You won't make as many careless errors as I might, since I'm not on graph paper. -3, -3, 4 is this point here. And then 1, -4. So over 1, down 4 is that point there. All right. So let's connect them with a dotted line. Then I draw a triangle. Now, for the horizontal and vertical sides of this triangle, I can just count, right? I can count units to figure out how long this vertical piece is and how long this horizontal piece is here. So we'll start with the horizontal. I went out 3 and over, so that's a distance of 4 units for this side. And this piece here down 4 and also up 4. I just want to make sure, yes it is. Okay, so that's a distance of 8. All right, so if the goal is to find the distance between those 2 points, I'm trying to find the length of that segment there. Well, I already said it's similar to Pythagorean theorem, or connected to Pythagorean theorem, because you have a right triangle, right? And if you remember, a squared plus b squared equals c squared. So these sides are your legs. That's your a and your b. So you can do 4 squared plus 8 squared equals c squared. 4 squared is 16, 8 squared is 64. You're back to that 80, if you remember when we just did the problem a second ago. And then take the square root of 80 to get c alone. We already simplified the square root of 80 in the last problem. We know it simplifies to 4 root 5. Okay? So, again, if finding the distance between 2 points, if you forget the distance formula, okay, you can always sketch it out and think about how is it related to Pythagorean theorem and solve from there. Okay, that's just another option, different way of thinking about that problem. All right, let me just see. I think I have one more example. Yeah, I just have 1 or 2 more examples quick that I want to go through. I actually did the harder stuff first, so these last 2 examples will be a little bit easier. Okay. So the next example, I just want you to identify the segment bisector and then find the distance of EF. So what I mean by that, I'll just write it down. Identify the segment bisector of EF, of segment EF, and then find EF. So knowing notation and understand what this question is asking you to do. When it says then find EF, what does that mean? Hopefully you guys remember that means find the distance from point E to point F. Find how long, what the length is of segment EF. All right, so let me draw a diagram. There's E, F, T, 2x plus 4. All right, so there's a lot going on in the diagram. Let's talk about it for a second. What do the tick marks tell you? The tick marks tell you that EM is equal to MF. Oops, I should do capital M, sorry. M is the midpoint of EF. Okay, so that's what the diagram is telling us. So if M is the midpoint, then what is ray MT? Ray MT, and notice you have to name the ray starting with the end point, the starting location going towards the arrow. So ray MT is the segment bisector. Right. So we did part 1. It says identify the segment bisector of EF. We did. We said that MT is the bisector. Then it says to find EF. Okay. Well, how are we going to find the length of EF? Actually, I already wrote something up there that's going to help us. Think about the first equation we wrote. EM is equal to EF. Think about a relationship you know. Since you know that EM is equal to MF, let's replace it with the expressions that are given. 6x is equal to 2x plus 4. I can solve for x. Let's subtract 2 from both sides. So you have 4x is equal to 4. X is equal to 1. So if x is equal to 1, I can substitute the 1 back in. I know that this segment from E to M is 6 units long. 2 times 1 plus 4, 2 plus 4. This is 6 units long as well, which it should be. So if we have 6 units and 6 units, the length of EF is how long? 12 units. And you could also use the segment addition postulate, right? We know that EM plus MF is equal to EF. That's a segment addition postulate. So 6 plus 6 is equal to EF. Therefore, 12 is equal to EF. All right, great job today, guys. Make sure you get your notes done for the day, and I'll see you back here for the next lesson. Bye.